We're starting our Pandas course now, and it's the last tool we're going to need before we start manipulation and analysis of real data sets. And we should be able to move swiftly through this material since many of the code conventions and syntax patterns that we discovered in our consideration of both Python and NumPy are going to also be applicable here in Pandas. And what we're going to cover is basic Pandas data structures, the one-dimensional series, and the two-dimensional data frame. We're also going to deal with indexing and sorting. We'll look at performing arithmetic operations, both in series and data frames, and aligning data across indexes and columns. We'll be mapping data from one data structure to another, applying functions to our data, and then doing some statistical summarization, aggregation functions, and correlations. I would like to give attribution to Wes McKinney again and his book Python for Data Analysis, which I drew heavily on in formatting the lesson trajectories here. And I would encourage you to get this book and to go through it yourself. There's going to be some aspects that he covers in more detail, some that I cover in more detail, and some that he covers but I leave out. But Wes was the original progenitor of the Pandas library, so it makes sense to go to the source. There is a point of housekeeping we need to consider before we move into the actual lesson. I'm running a virtual environment here. Also, I have the server running for Jupyter. So if you need to do that and you're not sure how to, we'd encourage you to go back to our Python for Data Science course in Lesson 2. And you'll see there that we install Python and then we launch a virtual environment, and then inside that virtual environment we install the Jupyter Notebook and get that running. So there's the support and help for how to do that. And then we use the Python installation package to pip install Pandas and Matplotlib and NumPy, which are the main libraries that we're using here today. So I'd encourage you to go there if you need some help in getting started. So with that out of the way, we can begin our Pandas course by looking at the Pandas series. And this is a one-dimensional array object. Now, as we mentioned, we're going to need to install Pandas for this, and we're using the alias, installing Pandas as PD, so that when we call Pandas methods and functions, we can just use the pd.alias to do that. And you'll notice here we're creating a variable called series1, and then within it we're passing this Python list. Now let me delete this so you can see the simplified function here. It's just pd.series in a capital S, and that's how we create a Pandas series. Let's do it. We'll run this code cell, and it returns not only the value but also the zero-based index for each value. And these are auto-incremented index starting with 0. So the fifth value is the fourth index because it's zero indexed. We can use the .values method to explore the values alone, and that returns all the values. Of course, if we add another value in here, like maybe 30, and run this again, we'll see that it just automatically auto-increments a new value. To explore the format of the index, we use the .index attribute, and we run that, and it says, yes, we're starting at 0 and we're stopping at 6. 0 is inclusive and 6 is exclusive, and we're taking steps of 1, right? So this is a one-step index. You'll recognize this format from both the Python range function and the NumPy arrange function, which we already considered. And you'll also notice that this is the same format for searching with splicing. So we can explore the elements of a series just with square bracketing. You notice the third indexed element here is a 20, so we can just use square brackets, pass that index in, and it returns a 20 for us. So if we do fail to supply an explicit index, Pandas will give this auto-incrementing zero-based index for us as a default, but you'll notice with series 2 we're actually defining an index, and so we're passing 4 values and we're passing 4 corresponding indexes. So let's run this and see the result. So rather than the default numerically based index, we have a user-defined index here of strings rather than numbers. So if we run this index, rather than giving us the structure of the index like it did when it's the default numbers, it gives us the actual indice values themselves. Now, similar to requesting data with the square brackets, we can do that with the text-based indices as well. So if I run apples, it's going to return 5 because apples is the index of the value 5. And interestingly, we can actually return conditional values inside one of these bracketed requests. So let's run this, and you'll note that we only return values that are above 10 from this series.